everyone. This is your final lesson for Unit 2. This is your lesson on 4.8. How is trigonometric functions applied? So applications. Sometimes I think most times everyone's afraid of like application, like all these word problems. But I just want to assure you that this section is actually quite the opposite. You've just endured 4.7, which was really pretty difficult, right? Inverse trigonometry. So now we're going to apply all those skills into applications, but actually it's not that difficult. So you'll like it, okay? All right. So part 1, angle of elevation and depression again. Why do I say again? Because I feel like we've dealt with this a lot, okay? Now, at a point 200 feet from, oh, sorry about the spelling here, feet from the base of a building, the angle of elevation to the bottom of the spire is 35 degrees. And the angle of elevation to the top is 53 degrees. Draw a correct diagram to represent the situation, then find the height of the spire. Now, I think most often, I think a lot of you guys have a difficulty picturing what's happening. So I really want you to put yourself in this position. So you're walking towards this building, right? I'm sure you guys recognize this building. Like, what's happening as you're walking away from it or closer to it? And what's the spire? Spire is this guy here, right? Okay, let's highlight some of the important things. At 200 feet from the base of the building, the base is here, and you're going to go 200 feet. Yeah, and you know what? Let's actually start labeling this, okay? 200 feet. You're standing 200 feet away. Okay? Yeah, don't think it's such a foreign problem, okay? Or don't even think that it's a math problem. 200 feet from the base of the building, the angle of elevation to the bottom of the spire. This is called the spire, and this spire has some length, right? That we need to kind of find later, okay? Spire. We don't know what the spire's length is, but we're going to go, what happened there? We're going to call this guy H, okay? The height of the spire, okay? All right, and also the building also has a height. Let's call that guy X. I don't care what you guys call it as long as it makes sense to you, okay? All right, so we know that to the top of the bottom of the spire is 35 degrees. So that means bottom of the spire is here, so it's going to be 35 degrees. Okay, 35 degrees. Remember, angle of elevation always touches. So it's angle of elevation and depression. Angle of elevation always touches the ground. Depression always touches the sky, okay? All right, and the angle of elevation to the top is 53 degrees. So we're standing at the same place, but now we're going to the top. And the top is 53 degrees. 53 degrees, okay? Yeah, so does that picture make sense to you, okay? That's called modeling mathematics, right? Draw a correct diagram to represent the situation, then find the height of the spire. So all we need is H, okay? But we have X here because maybe we're going to need to find that first, okay? All right, so let's check this out. Okay, so we need to figure out this or this, but we're given these angles and we know this height, this length here, this distance, okay? So we have an opposite and adjacent, and we have these angles. So obviously we need a tangent, okay? So tangent, okay? Now, but we have two different heights, right? We have a longer height with the spire, and we have the shorter height, just the building. But if we know both, then we'll figure out the height here of the spire. All right, so I think that's easy to establish. But let's do tangent of the bigger angle, 53. So we're looking at this guy here. If you need to, you should draw it separately. You should draw it separately like this, and maybe you could draw something shorter like that. Okay, so that's 53, and maybe that's 35. If you need to, see the picture separately, okay? Do that for yourself. All right, let's keep going. Tangent of 53, what is that? It's the opposite. All right, what's the opposite? Tangent of 53 is the big one though, so it's going to be x plus h, and this guy is just h, so it's going to be x plus h over 200 feet. Okay, so we have that tangent. But you guys, don't we have another tangent that we need to establish, right? We need tangent of 35 degrees, right? 35 degrees, which is x over, oh, we forgot to write 200 feet here. 200 feet there. Everyone good so far? I hope so. Now, if you are struggling right now, then stop the video and try to make sense of it. Now, you have two mathematical equations, which are just algebraic equations, and you see that they have a common variable, x. Okay, so maybe we want to make the x's equal to each other. I don't know, okay? So you guys, let's take equation 2, and let's set it equal to x. X is going to be 200 tan 35 degrees. And you know what? I never calculate this right now. I'm going to say every time I see an x, I'm going to plug in 210x, 1035, because I know this is some sort of constant value. Okay? All right. Now, I'm going to go to equation 2, and I'm going to multiply by 200. Tan 53 degrees is equal to x plus h. All right? Because we're trying to get h. We're going to try to find h. All right? All right. Well, you know what? Let's actually isolate the h. So what does h equal? I'm going to switch around a couple of things, but hopefully you can follow the algebra. Let's leave the h there. I'm going to subtract the x. So I get 200 tan 53 degrees minus x. And that's going to give me h. See if you understand that equation here. I let this be. I subtracted the x to the other side. And I got this equation here. Okay. But don't you know what x is? Yeah, you know what x is. So let's replace that. H is equal to 200 tan 53 degrees minus 200 tan 35. And you know, you guys, I never use a calculator more than once, and I never approximate values more than once. There we have it. Go ahead and plug this into your calculator right now, but do one at a time, okay? One at a time. So I'm going to do that right now too. Okay, I'm going to go 200 on my calculator. I'm going to do little by little. Make sure you're in degree mode for this case. Okay, degree mode. Degree mode, I get 200 tangent of 53 degrees. And look, I just do one at if you want, you can do it all at once, but make sure when you do it all at once, you actually parenthesize them. Can we make sure that we parenthesize them? Okay, so I got minus, I'm going to plug in 200 tangent of 35 degrees. And I hope you got something like this, you guys. The height, which is the spire, right? Which is a spire, I got about 125.367 feet. And let's make sure that the question asks for the spire. It asks for the spire. Now, I could also ask you for the building, so make sure you know how to find the building as well. Easy peasy, right? Just tangent, basic tangent, okay? Let's move on to the next question. But you know, you guys, why don't you try this one on your own? It's actually pretty simple. Stop the video. The angle of depression, I told you, always touches the ground, touches the sky, okay? Of a buoy from top of the Barnegat Bay Lighthouse, 130 feet above the surface. Label your pictures. Find the distance x from the base of the lighthouse. So we're looking for this guy here. Okay? And you know this is 6. So one thing I'll tell you is that you guys should remember from geometry class that this angle here and this angle are congruent. You know why, right? Because of alternate interior angle, so you know this is 6 degrees. Okay? So that should help you. And hopefully you set it up as tangent of 6 degrees is equal to 130 divided by x. Ta-da! And then you solve for x. But you guys, don't round anything, okay? 130 degrees, I'm sorry, not 130 degrees, right? 130 divided by tangent of 6 degrees. In your calculator, parenthesize, and then divide that, okay? And then make sure you're in degree mode, all right? And you should get something like this. Okay? Oh, something with the x's, okay? I'm sure it's a fixed 3, okay? Always. Well, let's move on to the next example. I feel like if you can stop the video and you can try it on your own, that's okay with me too. Oh, this next one here, making indirect measurements, is also a pretty good one. And I think that's going to be it, you guys, okay? Bear with me, because I think you can try this one on your own, try on your own, and you can also try this one on your own. They're all similar to this one here. Oh, looks so tricky, right? But it's not so tricky, Dicky. Don't even panic, okay? All right. From a building that's 100 feet tall, you see this 100 feet tall building, imagine Miss Chang's about 5 feet. So how many Miss Chang's required for this building, okay? 100 feet tall building, Altaget Hall. A man observes a car moving toward the building. A car is moving toward the building. You see this car? It's moving toward the building. Okay? If the angle of elevation of the car changes from 22 to 46 during the period of observation, how far does the car travel? So you can see the picture here. It's already depicted for you. For the test that's coming up, you should be able to draw these pictures on your own and imagine it. Okay? All right. So you see why these are equal, right? Because they're alternate interior angles. Okay? So I'll say these two angles are equal, and then these two angles are equal, 46. Okay? And you know, I think it's really beneficial if you actually draw the pictures separately too. So So you have this picture here, but you actually have this picture here too. Okay, 46D, 100, 22 degrees. Oh, degrees here too. 46, and this guy, whole thing, right? It's x plus d, and then you have 100 here, 100 feet, 100 feet. I think that picture should help you. Okay, go ahead and set it up using your, sine, cosine, or tangent. I hope you're smart about this. Think about what you have. You have the opposite, and you have the adjacents that you need to find, and you also have this angle. Okay. Whatever you do, you're looking for how far does a car travel. So you're looking for this guy here. Bam, bam, bam. Show me your notes when you get to school, but your x should be 150.9 bang, bang feet. Okay? And remember, you only round once ever when you're doing problems like this. All right? You might have to set up two equations. Okay, I'm going to give you some hints. Set up for one variable, okay, and then solve. Okay? Okay, good luck. Oh, and you guys, go ahead and try the next two examples. This one, maybe we'll do it in class, okay? All right, have fun.